Guys, so we are Yilan, Asta, and Ameya, and we're here to talk to you about a distributed project which is known as BlobTag. So the idea behind it is that we wanted to make a decentralized multiplayer game. We wanted to have a desktop client to render gameplay, and we were planning on using a backend P2P service to connect directly with other users when needed. So we got the inspiration from this game from agar.io, which is an existing game, and we want to show you a quick demo of how that works. So the basic concept behind it is that we have a blob, which you control using your mouse, and it can move in any direction. And your job is to move around and eat the small food pellets that you see and any smaller gamers that you see without getting eaten yourself by a bigger blob. As you eat the blobs, your size increases, which makes it more and more difficult to evade the bigger blobs. And once you get eaten, that's it, game over. So the motivation behind this is that agar.io has become viral ever since it was released in 2015, but the current model that they're using is still a centralized version, and with hundreds of players playing online simultaneously, there's a lot of load on the servers, there's a lot of information that travels back and forth from the servers, and all of that is unnecessary, and it really worsens the lag when you play the game. So our idea is that we want to develop a P2P version which can be used without any cost to the developers, and it can also get rid of some of these problems that the current model of the game is facing. So the game features that we're going to implement are going to be pretty similar to the game that you just saw on the video. We're basically going to have a two-dimensional map where each user is represented as a circular blob. The movement is going to be pretty limited, but we're going to have fixed speed and we're going to have fixed directions in left, right, up, or down. As you saw in the video, the blob is going to grow in size on swallowing food pellets or on swallowing other users. So we have a couple of implementation ideas. We're going to use Golang to create the application. This will consist of implementing the P2P functionality, allowing the user to control the game, and updating the game state on the GUI. Each user is going to be a P2P client, and it will join the game by connecting to a known website using DNS. After that, it will communicate to nodes that are close to it to send and receive updates about the game state. This is very similar to the CAN model that we saw in class, and we have a graph of it, which is taken from the slides, just to remind you of what it was. So our system architecture consists of the backend and the front end. For the front end, we're going to have a desktop application which is going to run a graphical user interface, which basically displays the game state. And as you saw in the video, the user can see their own blob and all of the others in their immediate vicinity. And the user will also be able to see the changes in direction and the size of the users in real time. The backend will be publishing the change in state to a subset of nodes in the network, which are visible to the user at any particular time, and it's going to use the P2P framework, as we said before, to do so. So we're going to use the model view controller design to implement the game, which is a pretty common design for games in general. It consists of a view, which is basically a GUI. Your GUI sends information, or it takes input from the user and sends that information to the controller, which then gives that information to the model, which in our case is the P2P network. So when a new user joins the game, the UI or the desktop application sends a join game request to the game controller. The game controller creates a new node and has a random position, which it sends to the P2P framework of node A, and this framework goes to a pre-existing website, in our case p2pagar.com, and it sends a join P2P request along with the new position. It also gets back all of the information about all of the neighbors, which the new node is going to have, and after that the blob is displayed and the user can start playing. So for updating state, the game controller sends a change direction along with the new direction and the position of the blob to the P2P framework. The P2P framework then communicates with the P2P discovery service in order to get all of the nearby nodes, and all of those nearby nodes are then to get all the nearby nodes, and then the new direction is multicast to all of the nearby nodes in that framework. So the messages we have, as discussed in all of the previous flowcharts, are join, change direction, change size, and consume. All right, so let's talk a little bit about the skills challenges. I think one of the major challenges we're going to have is learning Golang, which is a new language for us. None of us have ever used it before, so that should be pretty exciting. The other thing, I think one of the hugest challenges we're going to have is how are we going to discover all of the neighbors in a particular screen. So location-based discovery of nearby nodes in the game is going to be really difficult because we don't want to broadcast information to all of the nodes in the entire game, but just to the nodes which are nearby to our user. We also want to build in fault tolerance, which means if a user fails or is unable to respond, then we need to be able to handle that without breaking the game. And finally, as we mentioned, one of the major issues with the centralized version is lag. And that might be an issue with decentralized version as well, because we are going to send a lot of information to nodes. So we want to be able to deal with that so that we can make it a pleasurable experience for the user. Thank you. Do we have any questions?